everyone. Thanks for joining me today. So, I'll be speaking about our use case internally at EDB and how we used Airflow to orchestrate wide variety of workloads, including MLOps and also, analytics engineering workloads as well. So, a quick note about me. So, I'm Karthik. I'm from Toronto, Canada. I've been working with Airflow for 4 years now, and I'm a principal engineer at Enterprise DB. Uh, and my focus areas have been around analytics engineering, machine learning, and most recently into LLM ops and AI space as well. So a quick note about my employer. So we are the number one contributor to Postgres, open source Postgres, and we enhance, provide new features to open source Postgres in a way that it is better suitable for analytical and also AI workloads. And we believe that Postgres can handle everything. So right from your traditional OLTP workloads, it can also handle analytical and also AI workloads. That's a feature. And we have an Postgres data and AI platform that is built for traditional transactional, analytical, and AI workloads. Right? And a quick note about our latest platform. It's called Hybrid Manager, which allows you to deploy it anywhere on any cloud or even on-prem and have cloud-like functionality or cloud-like features. And it comes with observability baked in. It comes with support for analytical workloads, and also you can migrate to Postgres from other DBs like Oracle and so on. So let's take a moment to talk about how it used to be at EDB 2 years ago. So I think most of us are very familiar with this slide, right? So we have seen enterprise, situations where you walk into a team and then you see like each department is owning their own version of a database, their own version of reporting, and there is no single truth across the enterprise. And that's what we had. So this was a pain that we wanted to solve for us, in the sense that we wanted to generate a single source of truth coming across our complete enterprise. And we were looking for an orchestrator to do that, right? So basically, collect the data sources from across the enterprise and then put it into a centralized data storage or a data location, and then use it for downstream analytics, downstream purposes. It could be analytics, it could be machine learning, it could be data science, or whatever the workloads could be. And so quick note about our transformation journey. So we did not do this as a big bang. So we planned it out in phases. So initially, as part of phase one, the key thing which we were very much focused was on getting the data centralized and getting structured data into a single repository so that we can give the confidence to our end users to say like that's the single source of truth which you should be building your AI workloads on. And then as we work within Postgres, we believe Postgres can handle everything. Our data platform is Postgres, and we use a Lakehouse version of the Postgres for that. So I'll speak a bit on that. And then the next layers that we built on were around the enabling BI and also analytics workloads and decision science, basically around machine learning and MLOps. And finally, we set up a governance layer across everything so that we are aware of what happens within our ecosystem, and we track the data lineage from the source over to the end. And we will talk about the tools involved on how we achieved it, and Airflow also played a huge role in that. So why Airflow, right? So we had like a couple of key points that we wanted to focus on. So first thing, we needed a code-based orchestrator, and Airflow fits the bill for us there. And we needed something which has a vast ecosystem of operators. We needed something which has greater flexibility to handle anything thrown at it. So think of your regular data ingestion workloads. Think about your machine learning workloads. Think about your LLM ops. Even that's I've seen use cases of people using that, and we are ourselves progressing to that space. And And also the another key factor that was very important for us was on the scalability side of things. So we wanted it to scale as we scale with our use cases. So and Airflow fit will build wonderfully for us as part of that. And I love the community. So that was one of the most important things for us. Like I was really surprised by the progress that we made with Airflow within in the last couple of years. And you blink an eye and you miss a lot of things, right? So I had experience using Airflow with past Airflow 1.0 as well, and then experience using it for with 2.0, and then I'm really stumped and really surprised with what 3.0 achieves and what type of use cases it uncovers for the business, right? So that's a great it's a great community effort. So this is an high level architecture. Like I just wanted to show on how we achieved our analytics transformation. So as I spoke, we have our hybrid manager that sits at the center of it, which is an Postgres distributed lakehouse, which with support with PG Vector. PG Analytics Accelerator, that's what we call for enabling analytic workloads, and AIDB. It's also an extension on top of open source Postgres, which allows you support for AI workloads. And Airflow plays a key role in each and every step of the way, right? So right from getting structured data into our lakehouse, and also with the unstructured data, putting it into a necessary location and bringing it into our ecosystem. And we use DBT closely coupled with Airflow. I'll talk about that a bit, in a bit as well. We use Azure Cosmos to actually drive DBT workloads, and closely followed by like we have data quality also embedded into our Airflow ecosystem, so that we can clearly understand how the data moves from one location to the other. And finally, we serve it up to our end users through BI and database tools. So how did we, decide to implement this, right? So basically, it was a huge undertaking at an enterprise level. So we had to do it in a phased approach. So we broke down different tasks. We approached it in like small wins that we could do for the team. So we initially started with creating pipelines for the most major mission control dashboards across the enterprise, and that was the first win that we took. And we slowly transitioned into analytics engineering. And since DBT allows our analysts to be focused on SQL without leaving the ecosystem, so that's what we brought it into the mix. And then we learned, we iterated, and we built reusable patterns. So I will talk about this a bit as well, like in the sense of reusable patterns. Basically, we ended up like initially, like that was one of the big lessons learned for us. We ended up writing a lot of repeatable code for a lot of use cases before we actually took a step back and said like we need to organize something. Then we created an internal library of utils which would be used by multiple use cases down the stream. So that's a key thing that I encourage like everyone to take note of, like at the initial level. And like typical examples of the use cases that Airflow supports us, it supports with the data ingestion, as we that's a good use case, initial use case. And then it supports our reporting analytics. Like everything is driven through Airflow now, so all the pipelines are driven through Airflow. It supports our data quality checks. These checks are embedded within each phase, and we set them up to fail fast and fail loud, so that we are aware of what fails. And most importantly, the things that I'll be diving deep in today are around the machine learning MLOps space, and also on the analytics engineering space, DBT. So Cosmos was a wonderful tool for us in bringing DBT workflows to Airflow. So prior to Cosmos, I've used DBT, but we had to use either a bash operator or a direct a regular cron job running DBT workloads typically, and it lacked or it did not give us the insights that we needed at the task level. And what Cosmos does is, for example, like you're seeing a typical DBT project for us, shown here, like it's on a churn DBT project, and we have like around close to 95 models as part of this project, right? And Cosmos brilliantly turns each and every model into an individual task, which we can track with retries enabled, so that if anything fails, we can look at that as well. So since I couldn't paste like 100 different tasks on the screen, I just took an example project that we did. So this is how it looks like. So you can drill deeper into different task level coming out from Cosmos. And each of the model within your DBT project, it converts as a task. And this is another use case that we did at our organization. So we were working with a high volume data set, and we needed a way to convert this data into a Delta format. And one of our extensions, like the Postgres extensions, allows you to query the Delta tables sitting within your S3 as a native SQL table registered within the database. And Airflow, along with Polas, we were actually using Airflow to convert that to Delta and write it to an S3, register it, and then your regular cycle follows, like the DBT and the data transformation analytics engineers, they work with that particular data set, and then they create additional data sets on top of that. So like PGA, like it allows fast columnar query engine for Postgres, like so you can see 30x faster queries coming out of it, and Airflow like orchestrates everything around it. So some of the data quality gates that we set up for ourselves. So DBT tests drive all of our DBT models. So any DBT project comes within its own tests, and we use Soda Core for data quality checks elsewhere. So think of your data ingestion tasks, or think of your machine learning tasks. That's what we use. We use Soda Core for YAML-based checks elsewhere, and for failures, we trigger alerts through PagerDuty and to Slack. Like for warnings, we use Slack for dedicated alerts. And so what are some of the results and impact that we saw, right? So the first thing that we enabled for the enterprise was to have a single source of truth for all the reporting KPIs. And we finally had some best practices for data processing and management within the company. And we saw reduced time to production for data products. So the tasks that were taking like multiple weeks for users to actually generate, put products into production, actually like that got reduced to hours. And another key feature that this enabled us was to have around the governance area, where it allows us increase data lineage and improve data quality for all our sources, like so that we could provide that confidence for the end business users. So finally, stepping into MLOps. So MLOps is a bit of a different beast, in the sense that it's not a single script that you would be writing or you would be orchestrating. So you need to be taking care about data versioning, experiment wrapping, model registry, deployment, monitoring, and retaining. So this is what makes it a bit difficult, or I would say a bit challenging. But how we achieved is that we used Azure Machine Learning as our MLOps provider, and Airflow actually complements Azure Machine Learning. So we did not enable Airflow to do everything. So Airflow is a better complement. Azure Machine Learning does what it does best in registering your models, in tracking your experiments, in all things model and serving the models basically. And Airflow does what it does best. It just orchestrates, right? So that's what we enabled within our enterprise as well. So these are like quick snapshots of the training and inference pipelines that you could see. So we start like by extracting training data, like you're doing the feature engineering, all sorts of phases with respect to the training. And then you have quality gates embedded into your pipeline so that you'll fail fast. And once you only register your pipeline after a certain quality gate decision has been made, and it registers in a new version. similar with an inference pipelines, where your inference pipelines will get called at a regular scheduled date, and it picks the latest version of the training model that's available within the repository. And we had model monitoring as a separate Dagora pipeline that runs in our environment. So specifically, we set up like data drifts, model accuracy, and these sorts of things. And some of this we lean on Azure Machine Learning to provide us, and some of this we actually wrote ourselves as independent, logic. And then, like, as part of the model monitoring, if it evaluates that you need to there's a fall in accuracy, or you need to set up a retraining again, then it automatically triggers retraining job files based on the latest data again it collects as of that day. I like to talk about like where we are on our journey as part of the phase 2, right? So I know this is a bit complicated slide in the sense that I try to put everything in this, but just bear with me. Like from where we started, we are trying to centralize our data and have an understanding of where data exists within our enterprise ecosystem, and where we are taking it is we are setting it up with the governance and the right security in place, so that users can actually bring their own AI models, or you could use embedded AI models within the enterprise, and we'll be in a position to actually support that. And we are looking at Airflow to actually drive a lot of that as part of our LLM ops as well. Maybe which, like, as we go about that, we can discuss more on that. Right? And so some of the design patterns that I followed, right? So within the enterprise, so we had some patterns for DAG naming convention. So specifically, team use case frequency. That's how the DAG should be named, and DAG owner is a very important thing which we use. Like, we are using a monorepo right now, since our use cases, since the teams that are using Airflow at the enterprise level are pretty small. So but we see a need to actually move away from monorepo. So that's another thing. So as you, it states that as you start your journey, you can start small and start simple. Monorepo allows you to do that. And then we use custom XOM backends. So we have Azure Storage Blob configured as a custom XOM backend with JSON and Pandas serialization. And we have a custom secrets backend as well, which allows us to securely store secrets outside of the Airflow ecosystem. And there was a need for us to create a custom operator specifically. We were working with an Kubernetes application that was exposed behind Teleport. Like, if in case you have heard of Teleport, it's an auth network. So we had to create a custom operator in Airflow, which would handle auth and also does access to the Kubernetes app for us. So that's a great thing that we could extend Airflow as our use cases evolve, right? And when it comes to alerts, like, we have standard like Slack email alerts for warnings and PagerDuty for failures. And important, like the final thing, very important, was having the virtual environment for TPT. We had a lot of lessons on that. As our use cases grew, we were seeing we had a lot of conflicts with respect to package dependencies, and having virtual environment really helped on that front. So lessons learned, right? Documentation, that's the key. We are still evolving, we are still learning. We are still not perfect, but it's very important for you to be invested in documenting what you're doing, so that it becomes easier for onboarding new engineers onto the project. And focus on observability from day one. Like, you need to have monitoring and logging setup so that you know what's happening anywhere within your ecosystem, and also you are able to track basically the assets that you're creating. And another thing was another important lessons learned was on reusing components. Specifically, like, as I said, like, we were recreating a lot of similar logic for multiple use cases, and then we learned and we took a step back, and we had to create reusable components for that. And finally, like, CI/CD and change management, like, since our use case was simple, but it evolved as well. We use Astronomers managed Airflow because like we were lacking a platform team ourselves to manage Airflow for us, and we wanted to do what we do best, that is work with Airflow rather than manage it. So we took the help of Astronomers team there, and it's been wonderful. Like we never had any incident from our environment, and we really like it took the managing aspect of that from us. So so if I leave you with some key takeaways, right? A couple of things. The first one is always build in phases. Understand that you cannot do you can't deliver us everything, or you can't modernize everything within a month. So set the expectations right, build in phases, start small and then start iterating on that. uh, and with respect to pipelines, treat your pipelines as production software. So bring software engineering best practices to Airflow pipelines as well. Have version control, have monitoring, have automated tests that would track new PRs coming into the environment, so that you would know like if something goes wrong. And finally, like Airflow is amazingly flexible in the sense that it can take care of anything you throw at it. Like, so you can take care of regular data ingestion, it can take care of analytics engineering, it can take off machine learning ops, it can take off LLM ops. You just need to be aware of what it works as best. So it works best as an orchestrator, so we need to set it up to use it as an orchestrator. And finally, eliminate code duplication and build reusable components. That was an important thing. Thank you so much.